want to prove that the opposite sides of this parallelogram are congruent. Alright, we've done this a few times too. This is a little bit of a lengthy proof. We're going to start off with, as always, our given information. And what's given here is a parallelogram, meaning that BC is parallel to AD, and similarly AB is parallel to CD. Okay, I'm just saying those opposite sides are parallel. The red side over here is parallel to the red side over here, and then the blue side up here is parallel to the blue side down here. Okay, that's what's given. Now, if you remember how we start this problem, we're going to have to add our own diagonal here. We're going to call that angle 1. Let's call this angle 2. Let's call this angle 3. Let's call that angle 4. Doesn't matter what you call them. You could call them 6, 7, 8, and 9 for all I care. Let's just label those angles there. And where we're headed is a triangle congruence proof here. Triangle congruence proof. So the first thing I'm going to say is that angle 1 is congruent to angle 4. How do I know that? Here's angle 1. Here's angle 4. And what we really have happening is this transversal coming in with a parallel line and a parallel line. And so this is, well, sorry, let me switch that around. Parallel line and a parallel line and a transversal. This is kind of like our angle 1. This is kind of like our angle 4. Those are alternate interior angles there. All right, alternate interior angles. So I'm going to write alt int angles theorem. All right, alternate interior angles theorem. The next thing I'm going to do is talk about angles 2 and 3. And it's the exact same thing. Those are alternate interior angles with our transversal here flipping over the line. So we can say the same thing about angles 2 and angle 3 are congruent for the same reason. Alternate interior angles theorem. The other thing you'll notice, I said we're headed towards a triangle congruence proof, and so what we have is this center line shared by both triangles in our figure, and if you remember what that's called, that is the reflexive property. So we're going to say that AC is congruent to AC. Reflexive property. Okay, and from here you can see that this triangle up here, and let's highlight this other one, this triangle down here, okay, so those two triangles, the blue and the yellow one, they are congruent. Why? Because we have an angle, side, angle in both triangles. So I'm going to say triangle ABC is congruent to triangle, and then the other one would be CDA. And our reason was angle, side, angle congruency. But we're not done. We're trying to prove these opposite sides are congruent. Right here and right here. Right here and right here. So we're trying to prove the red sides and the blue sides are equal. What allows us to fill in all the other information about the triangle? What allows us to just jump to that conclusion? And if you remember, we can say that BC is congruent to AD, and similarly, that AB is congruent to CD, and the reason is CP, CT, C. It comes back again. All right, CP, CT, C. So that proof's probably the hardest that we've learned, but definitely think it's doable.